So for this example, should we pick u equals to the numerator or u equals to the 8x plus 7? Or what about the entire denominator? Well, obviously this last one is not an option because it makes things even more complicated. Well, since we're debating between these two, let's try this option first. In this case, if I let u equals to 8x plus 7, du equals to 8 dx. And so the denominator part becomes u to the 1 over 2 power. The x I moved here. The 4 will be split into 1/2, which is taken outside, and the 8 dx, which combines to get du. But this cannot be integrated. We don't know how to integrate it because of this stupid x. But don't forget, u equals to 8x plus 7. So if I make x the subject, x actually equals to u minus 7 over 8, right? Then I could substitute this in here, which gives us this. But now what? This could be split into two fractions, right? Which is this. This is good because we know how to integrate this, right? This is like the reverse of the power rule. And after the substitution, we got the final answer. Now let's back up a little bit and let's try this option. Let's see what will happen. So if I let u equals to 4x, du to be 4 dx, and so x equals to u over 4. The integral will give me this, and if I combine this, I would get du here. But how do we handle this junk? If x equals to u over 4, then 8x will be 2u here. There's no way that you could integrate this because you have both u up and bottom and they cannot be reconciliated. So from what we've learned so far, this is no good. This is a question that involves e. So in this case, what should we pick for u? Well, obviously the x19 looks like some kind of derivative of x20, right? And so it's pretty obvious to pick x20 to be the u, and this x19 will be part of that du. So let u equals to x to the power of 20 and du equals to 20x to the power of 19 dx. So the x20 would become the u, and if we look at this part, we're missing the 20. So I add the missing piece here and with this balancing factor here. And so now when they are equal, I'm going to rewrite this as du. And this is super easy because the integral of eu is just eu itself. And finally, we sub it back for u equals to x to the 20. So for this question, we notice that this and this, that e to the power of 2x is some kind of derivative of itself. But we know that e to the power of 2x is also the derivative of this whole denominator. So should we pick this one for u or this whole thing for u? Well, let's try this first. So first of all, I let u equals to e to the power of 2x. And so du equals to 2e to the power of 2x times dx. And if I let the numerator to be u, then it's actually impossible to rewrite the denominator as part of the du. So it's no good. And on the other hand, if I pick this bottom e2x to be u, I could actually proceed by adding a 2 here and with this balancing factor. And this whole thing would be du. Well, but for this part, we know that the derivative of ln of 3 minus u is actually 1 over 3 minus u and with a negative sign for the chain rule. And so we know that integral of negative 1 over 3 minus u du would be the ln of this thing. And therefore, we just need to add this negative here, right here. And so with the negative here, this is the answer. And back with the substitution of u, here's the final answer. So what about if we take this option as u? Then du would be negative 2e2x dx, right? So similarly, I move this to right hand to join the dx, and this whole thing would be u. And this time I'm adding the negative 2 to match with the du here. So we're ready to go. This is just negative 1 over 2 times ln of absolute value of u plus c. And we end up with the same answer here.